Chapter 1, Section 1.1, Rectangular Coordinates, Introduction to Graphing Equations. The topics I'm going to talk about in this lecture are the distance formula, the midpoint formula, finding intercepts, and graphing with the TI-84. First, let's look at the distance formula. The distance between 2 points, P1 and P2, denoted by d, P1, P2. And the d just simply means distance. Now you want to write this formula down because it's going to help you with your assignment, and you can also use it for the test. Let me show you a quick proof of how we come up with the distance formula. So here's my P1, point 1, and here's my point 2. And this is the distance between the x values, and this is the distance between the y values. And what we're going to use is the Pythagorean theorem. C squared equals a squared plus b squared. So c squared is your hypotenuse, so that's d. So d squared equals, and we're going to use this as our a, x sub 2 minus x sub 1 squared plus, and this will be our b, y sub 2 minus y sub 1 squared. Now remember, we don't want to know what d squared is, we want to know d. So that's why we take the square root. And so that's how our formula is found. Let's look at an example. Find the distance d between the points 2, 5 and 4, 8. So here's my distance formula waiting there for us. And before I start, I like to label x1, y1, my first point, and x2, y2, my second point. It's just easier, and it saves me from being confused which is which. So let's just fill in what we know. x2 is 4 minus x1, which is 2 squared, plus y2, which is 8, minus y1, which is 5 squared. 4 minus 2 is 2 squared. 8 minus 5 is 3 squared. So we have 4 plus 9, which turns out to be the square root of 13. Now the square root of 13 does not reduce because a perfect square does not divide evenly from it. So this would be our answer. Let's look at this example. Find the length of the line segment shown. So here's a picture from our calculator. I'm going to call this x1, y1, my first point. And I'm going to call this one x2, y2, my second point. Here's my formula written out, so all we have to do is follow it. x2 is 3 minus x1, which is negative 4 squared, plus y2 is 2 minus y1, which is 5 squared. 3 minus a negative 4 is 7 squared, plus 2 minus 5 is negative 3 squared. 7 squared is 49, plus negative 3 squared is 9. So we have the distance of 58. And there isn't a perfect square that divides evenly into 58, so this turns out to be my distance. Next, let's look at the midpoint formula. The midpoint m, x, y, just an ordered pair, of the line segment from point 1 to point 2 is this formula. You're going to want to write this one down too. So let me kind of show you how this works. X is basically, we're finding the distance between the two x's, and we're dividing it by 2. Basically, we're finding the mean. And y works exactly the same way. And so that's how our formula is found. Find the midpoint of a line segment from P1 to P2. So here's my formula. Hopefully you've So let's look at our first example. Find the midpoint of a line segment from P1 to P2. First, we're going to write down our formula, and now we're going to find it. So M, which means the midpoint. Now once again, if this is P1, it's x1, y1, and if I can squeeze it in here, x2, y2, just like before. So we're going to have x1 plus x2, so we're going to have 3 plus 1 divided by 2. Make sure you put your comma in there. And then we're going to add the y's, so negative 5 plus 7 over 2. And we're going to continue. 3 plus 1 is 4. Negative 5 plus 7 is 2. And so our midpoint is 2, 1. It's that ordered pair, 2, 1. Now sometimes you can have a fraction. And remember, if this ends up being a fraction, you always want it in lowest or simplest terms. Now let's talk about the y-intercept and the x-intercept for a minute, just as a review. The graph crosses or touches the y-axis. That's your y-intercept. And the x-coordinate is always 0. And let me just draw a coordinate plane here. So here's my x-axis and my y-axis. Now remember, we're talking about where it crosses the y-axis. At this point, it either crosses or touches. At this point, x is always 0 and y is some number, wherever it is on the axis. The x-intercept, the graph crosses or touches the x-axis. The y-coordinate is always 0. And once again, it follows the same idea. So let me make my little coordinate plane here. Here's x and y. But this time it's crossing somewhere on the x-axis or touching. And at this point, we have some x value wherever it's at, and then y is always 0 because it's nowhere on the y-axis. So let's look at this example for a minute. This is an x-intercept, x-intercept, x-intercept. Because remember, it can touch or actually go through. Here's a y-intercept. Another y-intercept we could have is something that looks like this, where it just touches right here. Let's look at this example. Find the intercepts of the graph. So I'm going to find the x-intercepts, and those are very easy to find because you just look at your x-axis. Here's one, negative 3, 0. Here's the next one, 3/2, 0. And here's the next one, 4.50. The y y-intercept is exactly the same. You just look at your y-axis, and wherever it touches or goes through is your y-intercept. I'm going to talk a little bit now about the calculator. I know a lot of you are very familiar with the TI-84, but for those of you who haven't used it for a while, I just want to refresh your memory. If you've never used the TI-84, this is the best and perfect time to start learning. We've been talking about graphing, and when we look at the TI-84 or 83 calculator, and we look at the graphing part, you're going to see something that looks like this. And I'm going to show you on an actual calculator in just a minute. But what does all of this mean? Well, x-min means the smallest value of x shown on the viewing window. So if this is my viewing window, the x-min is actually -2, 1, 2. The x-max is 1, 2, 3, 4. The y-max is the same idea. So the y-max is the largest value of y shown on the viewing window. So the y-max here is 1, 2, and the y-minimum is 1, 2. Y-scaling and x-scaling are the number of units per tick mark on the axis. So in this case, if the x-scaling is 1, that means each of these is worth 1. So 1, 2, 3, 4, just like I've been counting. If the x-scaling is 2, that means every tick mark is worth 2. So we have 2, 4, 6, 8, and so on. If the y-scaling, once again, is just 1, it's 1, 2. If it's 2, it's 2, 4, and so on. I always suggest never changing the x and y scaling to different numbers because it's just confusing. So if your x scaling is 1, keep your y scaling the same thing. If it's 2, make it 2, and so on. So here's another picture of a calculator. And when we look at it, our x minimum is -3, and our scaling is 1. So what that means is, for every tick mark, it's worth 1. So 1, 2, 3, and that's how they get -3. And then we have 1, 2, 3. When we look at our y min and max, the scaling is 2 in this instance. So that means every tick mark is worth 2. So 2, 4, 2, 4. And like I said, it's not a good idea to have these different, but just an example to show. So here's the calculator that we're using for this class. And I just want to really show you what I'm talking about here on a real one. So I'm going to go into y equals, because I'm going to plot a graph. I have 2x plus 1 in there right now, and that's what I want to graph. So I just click graph. And here's my picture. This is actually the standard viewing window. And what that means is this is 10, -10, +10, -10. If I want to change this, it's really easy to do. You go over here to Window, and you click on it. And you see we have our x-min, x-max, x-scaling, y-min, y-max, y-scaling. This x resolution, leave it alone. I never touch it, so that's a no-no. But as you, just like I said, this is the standard, so -10, 10, -10, 10. Let's say I want to change it to something different. So let's put -3 for my x-min and 3 for my x-max, and go down. Let's put let's try -20 for my y-min and 20 for my y-max. And I'm going to keep my scaling the same. And let's see what that graph looks like. And here we go. Let's look at our x-axis here for a second. We have 1, 2, 3, because remember they're all worth 1. Then we have just a whole bunch of them here because every little hash mark, every little tick is 1. Let's change this though. So let's go back to my viewing window. Let's change the y. And let's change that to, oh, I don't know, -5 and 5. And let's see what that one looks like. So once again, here's our 3 and 3, but now we have 1, 2, 3, 4, 5, -5 and +5. One more time, let's go in there and change these to -20 and 20. But this time we're going to change the scaling to 5. That means every tick mark is worth 5. And we're going to change this to negative 20, 20, and 5. And let's graph that. So now we have 1, 2, 3, 4, but it's not 4, because remember, every one of these is worth 5. So it's actually 5, 10, 15, 20. 5, 10, 15, 20. And so that's how you can change the viewing window and get a better idea of what you're graphing. And it also helps you to find your x and y intercepts. Find the coordinates of the point shown. Assume the coordinates are integers. We also need to assume that every hash mark is worth 1. And we know that because we have a negative 3 here. So that means negative 1, negative 2, negative 3, negative 1, or positive 1, sorry, positive 2, positive 3. But if this one's a 4, this has to be 2, 4. And if this is negative 4, it has to be negative 2, negative 4. So this ordered pair, the x-coordinate will be negative 1, negative 2, and the y-coordinate will be positive 2. So now what I want you to do is I want you to do your 1.1 homework. Make sure you look at the calendar that's in my math lab just to make sure you're keeping up. Homework completed after the due date will be deducted 10%. So make sure you get all of your homework done.